Hey, Chris. How are you? I don't have a digital copy. I don't think I will try. I'm looking for that. I just have a hard copy of the review. So hang on just a second. I actually might have, but I'm checking. Um, but if not, what I'll do is read the problem and then I'll work it out. That's the best thing I think I know how to do. Ah, hang on. If you want to text me in the chat box if there's one in particular that you'd like for me to start with, or if you just prefer me to work through the whole review, I can just say start with number one, but just type in the box what you would like me to do. Are you there?
Oh, hey, Mrs. Burks. Am I the only one on here?
Yeah.
Oh,
It's
sorry. I was getting my I was in another room getting my book.
oh no, you're fine. You're fine.
I don't
Uh,
have the section review or whatever she gave in class because I wasn't there.
yes.
But is there like a
Oh.
way where I can see like how you did last time on the math lab?
Oh, yes, that's what I'm going to try to do, but you don't even have a copy of it, do you?
Yeah, I don't.
Okay. All right. Well, I'm also trying to figure out how I could possibly, I'm trying to finagle it where I can actually kind of make a copy because it's actually a Word document, which it won't come up in Google Docs. So I'm going to try to print it to PDF on my regular computer. And that way I can pull it up as a PDF and we'll just walk through it that way.
Oh, that makes sense. Thank you.
No problem. And since it's just you and I, it'll be a one-on-one thing and we'll walk through the whole thing.
Nice.
Yeah, it'll be personalized tutoring session.
Thank you. I appreciate it.
Not a problem. I mean, I'm going to be here anyway, so I just as soon be doing something than listening to crickets chirp.
Is it? Yeah, it's chapter 6, right?
Yes, sir.
All right. Thank you. I'm getting
Yeah.
my book open. It still has that new book smell. I never use it.
Yeah, well, yeah, I was going to say, and the thing about it is this particular chapter, woo, um,
For real.
yeah, I mean, like seriously, it, uh, um, this particular one, interestingly enough, uh, we're not even we only did two sections, I think. Maybe no, three. Did we
Yeah.
do three?
I don't think we even did Pascal's triangle, did we?
I do, but I'm gonna hook you up today and explain how awesome it really is. Miss Stone doesn't think it's as awesome as I do, but I really love Pascal's triangle. And I don't know if I think I might have tainted my class a little um uh, toward it.
Yeah, I'm trying to look at her now to understand it.
Yeah. Well,
I see the pattern because the right number is just advancing up.
yes.
Left.
Hang on. I can't type and talk at the same time. I either have to sit down or spit out my gum.
That's all.
Um, So I'm praying that this works actually. It's a wee bit of finagling, but I think it's going to be worth it if you can actually see the problem and be able to write it down. You know what I'm saying?
Yeah, thank you. Is there a way you can just copy and paste the document into Google?
Um,
Trying
it
to.
works better if I can make it a PDF because then I can write on it. That's the only thing. That's the caveat to it.
I got you.
Because I could cut and paste it into a Google Doc, absolutely for sure.
Oh,
But
yeah, just so you can write on top of it.
in order for me to kind of explain it to you, it just works better if can.
Do people like come on the math lab usually, or is it like?
Yes, I will tell you, Walker Braswell will more than likely show up about halfway through, and he'll be like, "Hey, Mrs. Sparks," and we'll probably, you know, go through it again. But it's all good. He entertains me. He entertains me.
Yeah, I don't know the kid terribly too well.
Yeah, I just he makes me laugh every day in class. But that's kind of what happens to me though. I don't know. I just have fun. Just have fun. All right, I'm getting closer.
Thank you. So on the calculator, when you have to do NPR or NCR,
Yes.
how do you know when it's choose or permutation?
Okay, that's a really good question. And I'm going to give you the hookup for that. Uh um Please, it's not here. Hang on. I just uploaded it and now I can't find it. Um, on the test that we're about to go over, uh,
Oh, that's a great idea. Just use the test for tomorrow to review.
well, actually, to be perfectly honest, I said test, um, but the what you're about to see is actually, um, I guess I need to refresh this. It's very similar.
Oh, the review sheet is.
Yeah, basically
Uh,
what she did.
yes.
Uh, Open with Cami. This way I can write on it. And then I'll open it so you can see it. All she did was take the exact test and change the numbers. So the exact format, the exact way, everything, it will be completely laid out.
Oh, when you say numbers, you just mean like the problem numbers or like the.
Yeah, like, okay, so in that first problem, you can see where it says you can purchase a new house in 10 different colors with 8 different shutters.
Mhm.
It'll probably be you can purchase a house with, you know, 8 different colors and 6 different shutters or something like
I
that.
think you just rearrange the order of the problems, not like change the letters or numbers in the problem. Okay.
Right. It just,
I-
yeah, like, I don't have it in front of me, unfortunately.
Oh, so for the first one, that would be NCR, right? Like 10.
Actually, that is a counting principle, and it's even easier than that.
Oh, so you just do.
Yeah, because it's the key is you got to read the whole thing because you've got 10 different colors, 8 different shutters, but then you also have the option of brick or rock. So that's going to be 10 times 8 times 2.
Well, that's all you do.
Yes, sir.
So how would like on the test, how would you understand that between that and like the choose or the one where you do NCR?
Okay, that's a really good question. Hopefully, as we walk through this, that will become a little clear between the counting principle and that is like when you're a lot of times the question is I can't really say that either. Um, When you see the word arrange, ARRANGE, which we're going to get down to at 6 and 7, those are always going to be permutations or factorials. And if you only have one number in the problem, like number 7, it says how many ways can you arrange 9 books on a shelf?
Maybe
That's only one number and it's one thing, so that's going to be a factorial.
and that's where you do the exclamation mark.
Yeah, 9 exclamation mark.
Awesome.
Okay.
That makes sense. Those two. Let's do like for the first one.
For number 6, how many ways can you arrange 12 students on the second row given a total of 32 students? Order matters. When you're arranging something, order matters. And when order matters, it's a permutation.
That's the NPR. So like you do 12p32.
It would be the other way around.
32p12.
Yes.
Oh, because it's the total number that goes first.
Yes. That big number usually goes first. That's how that rolls out. When I say usually, what I mean by that is, let's just say, for instance, how many different ways you could arrange all 32. There would be 32p32, but you technically could do a factorial at that point. But what I'm saying is there are going to be those circumstances where the numbers will be the same, but that first number should never, ever be bigger than the second one. Does that make sense?
Yes, ma'am. Yeah.
Okay. All right. So that first one, it's just 10 times 8 times 2.
That makes sense. So you get 160.
Yes, sir. So now, so on like tomorrow, it might not be a house. It might be a boat. It might be a barn or something like that. But it's going to come in different colors or different shades, and you can pick different options on whatever it is that you're going to be doing. But the type of problem is going to be exactly the same, and how you work it will be exactly the same. So on this top one here, it's going to be 10 times 8 times 2, which equals what, 160? Is that right?
Yeah.
Yeah, because that'd be 80 times 2, which is 160. Nice handwriting, don't you think?
Yeah, I mean, I think it's like ACSI material.
Yeah. Thank you.
Okay, the next one actually does really confuse me.
Oh, okay. So a license plate consists of 4 digits followed by 3 letters. How many possible license plates are there if the digits 1 and 0 cannot be used and no letter can be repeated? So let's just kind of break it down. Number 1, we know we're going to have a total of 7 slots because we have 4 digits. Yes.
Mm-hmm.
So I just, I'm one of those. I'm a very simplistic kind of thinker.
Oh, wait.
1, 2, 3, 4. So I know I've got those 4 slots. The next thing that I know is that 1 and 0 can't be used. So I've got, when I think about that, I know that 0 through 9 digits is really 10, is the number 10. Mm-hmm. Does that make sense to you?
Yes, ma'am.
A total. Okay, so if I take out 2 of those, which is 1 and 0, then that leaves me 8 possibilities for my 4 digits. So I'll have 8 times 8 times 8 times 8. Okay?
That makes sense. Oh, yeah, because that's
okay. And now I have 3 letters, but no letter can be repeated. So so my first one's going to be 26.
25. 24.
And yes, you've got it. You don't even need me.
Yeah, well, my grade will need it. I'll still get a 60 tomorrow.
No, you won't. No, you're going to rock this thing.
Sure.
You are. It's going to be great.
I mean, I can't say that about tests, but that helps a lot. That does make a lot of sense.
Okay, so just break it down and just, what you want to do. And like, I know it looks kind of weird, but like I literally would do this on my test. I would write those 7 lines and just break down exactly what it's saying and fill that in and then do your calculator stuff. Sometimes a lot of people, I take a little bit of extra time, to do that stuff, but it keeps me from leaving something out. Especially when you're dealing with statistics and probability, you really need to kind of have a process.
I got you.
Okay, the next one. A license plate consists of 4 digits followed by 3 letters. How many possible license plates are there if all the digits must be different? Okay, so now I've got 4 digits and 3 letters. So that's a total of 7.
Is that a
Once again, do you want to tell me what to write? You ready to go?
yeah? Would you if they're all different, would it be like 987?
Well, close, but remember 0 through 9 is actually 10 digits.
Oh wait, I see. Oh my god.
10, 9, 8, 7.
Oh, so
Hush.
you go down like that.
I'm sorry?
Oh, you see, you would sort of descending order for you just want to do 10.
Yeah, because once I used 1 digit, then I obviously can't use that one again. So then I only have 9 available to me. And once I use 2 digits, then I only have 8 available to me. And now that I've used 3, I only have 7 left.
Okay.
And it doesn't matter if letters can be repeated. So that means the last 3 blanks are all 26.
Okay, and you just multiply this all together.
Yes, sir.
Okay.
I'm sorry, Bill was out on the back porch, and so Guess insisted upon being back there with him. So that was her whining. Did you hear her?
I didn't, no, man.
Oh god, it's so embarrassing when my dogs. One time, Finn was snoring during math lab, and it was really loud.
That's funny. That's like my dog Chester.
Oh Lord Jesus. Okay, so for number 4, I know that you're kind of used to seeing things when it's written like this.
Oh, it's the same thing though.
But that's exactly what you're supposed to put that in is 10p4.
Okay, that makes sense. Yeah.
And then so it would be the same for 5. And you're good on the calculator with all that? You don't need me to walk you through the process?
Yeah.
Okay, good. Okay, so now we get to number 6, where it uses this word arrange.
So that's like 30p12, 32p12.
32p12.
Okay.
If you go ahead and put that in your calculator, I'm going to explain one other thing to you.
Okay.
Because you're going to get a weird number.
Yeah, with an error.
Actually, it should be like 1.081551316. And then there should be like an E to the negative 17.
Well, yeah, just E17. It wasn't negative. Am I?
Okay, I'm sorry. E17. The next one is a negative, I think. I don't know. There's one on here that I felt was negative. Anyway, it's E17 is really, this is scientific notation. They just don't put a 10. So you could write your answer as 1.08 times 10 to the 17.
Okay, so,
that's scientific notation. The other thing that you could do, to be perfectly honest with you, is if you were doing this, I don't know how well you know scientific notation.
I mean, I feel pretty good about scientific notation.
Okay. Well, you actually could write down all those digits that are there, the 10815511316, and then count out enough additional spaces that would get you to 17.
Oh, okay.
Moving your arrow like this arrow right here. So this would be 1, 2, and then all those additional numbers, and then add enough digits to get you 17 zeros. I mean, add enough zeros to get you 17 places. Does that make sense?
Yeah. So like if there's 9 spaces in that, so you just add 8 to it, 8 zeros.
Yes.
Oh, that makes a lot of sense.
1, 2, 3, 4, 5, 6, 7, 8. Yes, that's it. Perfect. You're a genius.
Not
like
really.
I say, you don't even need me.
Yes, that makes sense.
Okay, great. Okay, number 7.
But so anytime this is a range, it means permutation?
Yes.
Okay, sweet.
Now, on number 7, because you don't have 2 different numbers, yes, it's a permutation, if you will. But I don't know if you remember that first film that we watched.
The exclamation mark or whatever?
Yes, that's all you have to write on this one is just going to be this bad. But when you don't have to, I mean, this is all you have to put into the calculator.
You get like 30.
I think it should be something like this.
Yeah, that's what I got. And every time on this, like every time on the test, and when it has one number, that means you're going to do that?
Yes, let's go through the whole thing just to make sure Mrs. Sparks isn't lying to you. But yes, that would be the case. It's like one of those things that I'm like, yes, do that always, and then all of a sudden there'll be some little caveat to that rule, and I'm like, oh, I'm so sorry, but I cannot think of another situation at this present time that where you would not do that, especially if the word arrange is there, because that just indicates a factorial.
Now, would the next one be the same answer?
It's very, very close. But what you have to remember, way back to that first film, when you have repeats, which we do in this particular
Oh,
case,
yeah.
you have to account for those repeats because,
Like n over
so you would have what is it? Is it the number? I think there's 9 letters, I believe, in Tennessee. Yes.
uh 3 E's. Do you just say that's one repeat, all the E's?
And there's 4 E's.
Oh. Oh yeah.
Because there's 2 at the end. So you have to account for that. So that's 4 exclamation point. And then there's 2 N's. So 2 exclamation, and then there's 2 S's. So that's what you would put in your calculator. But let me warn you, please
Exclamation.
make sure you put 9 exclamation point and then divided by, and then open parentheses, 4 exclamation point, 2 exclamation point, 2 exclamation point, close parentheses, and then enter.
The whole bottom, yeah.
Yes, sir.
And that's all you do for that one?
Yep.
So basically anytime like how many repeats there are the same letter or letter, that's how many. So if there's like 5 N's, you put 5 exclamation mark.
Yes, sir. That's it. Perfect. You got it. Your answer should be 3,780.
Yeah.
Cool.
Oh, and it's okay, yeah, that makes sense. So the next one you would have 4 repeats. So would it just be 9 or
I
no?
think there's 7 letters in this one. Yes.
Yeah, so it'd be like 7 exclamation mark over 4.
Yep.
Okay, sweet. And then that gives you.
That's a cute little number.
210.
Yes, sir.
All right, that's the smallest number I think so far. And then the next one's 5C3.
Yep. And I think that should be 10.
Mm-hmm.
All right. Will you let me digress for just 1 second?
Oh yeah, totally.
Okay. I want to show you. This is the reason why I love Pascal's triangle. Remember how that, and I've got bigger ones, but I have a big one that I love, and I'll show that one in a minute. But the reason why I pulled this particular one up for this, remember how the problem was 5 choose C?
Yes,
ma'am. I mean 5 choose 3. See that right there? Where I circled it?
Yes, ma'am.
Look, Pascal's triangle.
Oh.
5 choose 3. You don't even need the calculator if you have Pascal's triangle, technically.
But if you know Pascal's triangle, you're.
Yeah. And I will tell you, Pascal's triangle is so easy because you just outline the whole thing with ones, and then this adds up to be 2, and this adds up to be 3, and this adds up to be 4. That adds up to be 6.
Oh, I see the logic. Yeah.
It's so easy, and you can do it all the way. You can do it all the way, and you don't really need the calculator. And that's what I do for expanding binomials too, personally, just because writing this particular thing out, this 5 choose 0 and all of that, that just gets really confusing. This is so much cleaner and neater to me.
Okay, and like you just have to memorize like the zeros at the top and like on the.
I just write it like this. And I know that this is this is to the 0 power. This one is a 0 power. And these are all zeros.
Okay.
I don't know if that makes sense to you or not, but.
I mean, it does, but I like the logic makes sense. Like where like the 1 plus the 4 equals a 5, the 4 plus the 6 equals 10. I don't know if it's like I should memorize it for tomorrow to like.
Yeah.
Look up.
Well, what I'm trying to argue for my class is to allow them to use the Pascal's triangle as opposed to their calculator for these particular problems, just because it's so much easier to identify that one little line. Because you'll see when we get to expanding the binomials.
Oh yeah,
how it works.
I think that's where I have trouble. Like all the stuff that we've done so far makes sense. Like up and through 13.
Uh-huh.
Like I so like 13 would be 25 C9. No, P9. My bad.
Okay, I'm trying to catch up to you. Okay, so 12, what did you get for 12?
12, that would 15 books from a list. I didn't do that. I was just, like those make sense now. So that would be
That's 15C4.
because you can choose four out of the
Right.
15.
Because order doesn't matter. And 13, order doesn't matter. So you're choosing people.
So
You're
25.
choosing books. So that's 25C9.
Mhm. Would you get the same answer if you did 9C25?
I don't think so. I don't know. You tell me. I've never tried it.
I'll check.
I I don't think so. I think it would give you an error.
It gave me 0.
It
So
did?
I guess it's the same thing.
Did you? Okay.
Yeah, every time you do a smaller number first, it gives you a 0.
Okay. All right.
Yeah. Unless it's already 0, then it's not an X0. Okay, so for make a table and histogram. Oh yikes.
Oh, isn't that going to be fun?
We learned
Okay.
these yesterday.
Huh?
And I wasn't even there, so
Yes.
I never.
It's really pretty simple. The only time to me that it gets a little uglier, to be perfectly honest with you, is when the numbers are really, really small. And I haven't looked at the test to see if they're really, really small. I hate dealing with little tables when the numbers are really small, but they're not on this particular case.
I,
You're going to be like, oh my gosh, Miss Sparks, that's so easy. Okay, so make a table and a histogram showing the probability of distribution for the random variable B, which is the number on a table tennis randomly chosen from a bag that contains 4 balls labeled 1, 4 balls labeled 2, and 2 balls labeled 3. So the probability for a ball labeled 1
mhm,
is how many balls are there?
4.
4. How many total balls are there?
Mhm. Um, 10.
Yes.
Okay. Sorry, all the numbers together, kind
No,
of.
that's okay. So then that reduces to 2/5, and you will type into your calculator 2 divided by 5, and that should give you a probability of 40%. So the
Mhm.
probability of pulling a ball out of the bag with the label 2 on it is the same thing because you have 4 balls out of 10, which reduces to 2/5. Or you can even plug in 4 out of 10, or you can look at it and say, oh, 4/10 is 40%. I don't know how quick you are with digits like that.
That makes sense on the bar graph because you would just put the first two up to the same, and
Yep,
uh,
that's it exactly.
the next one would be 0.2. So 3 would be 20%.
Yep.
That makes a lot of. So it's just a bar graph essentially.
Yep.
Why did
That's
they
all
call
it
it
is.
a histogram then?
Oh, I think that's the technical name for a bar graph.
Oh, okay. They said
that,
it.
that's the mathy, sciencey name for bar graph.
Okay.
Now, don't you feel? I mean, don't you feel smarter for knowing that?
I do actually. Yeah, I feel like my SAT scores are going to go up at least 20 points.
See, that's what I'm saying. We're just here to help.
Yeah, for real. So 15. Um, I did we do this yesterday?
No, sir, we did it Monday.
Oh, tossing a coin 15 times. Oh, so it'd be like 15 over 2?
So here's what we're gonna do. All right, this is, and once you get this, and hopefully I've got enough room to write this, but this is okay. The 15 times. This is all the choose stuff.
Oh,
And your
15.
big number is 15, choose 4. Okay? And that's because we're doing A.
Oh,
All
yeah.
right.
Okay, I got you. Yes, ma'am.
Okay. So what is the probability of getting ahead typically when you're flipping a coin? What's that probability?
50.
50 chance, 50/50 chance. So then what you do is you put that probability in here. And this is raised to this number right here, this second number in your choose.
Yes, ma'am.
This second parentheses is always the difference, and I could write it out if you, so that way you'll know for every problem.
Oh, that makes sense. I mean,
It's always the difference between 1 and whatever this number is.
mhm.
And then the exponent to this second one is the difference between the 15 and the 4,
Descending.
which is 11.
Oh.
Because 11 plus 4 is 15.
Mm-hmm. That makes sense.
And so then you plug all of that in your calculator, ensuring that you put in the right buttons every single time.
That totally makes sense. Is
So,
there another way to do this? Because I feel like we did it a different way.
uh,
Or is this the only way you can do it?
I think this is the only way you can do it.
Okay.
I mean,
It's a problem.
she has a fraction instead of 50%.
No, I think I see where she's going. Okay, I think it makes sense.
She would have done this in class with you on Monday. Does that look familiar?
Um, oh yeah, it does. Yes, ma'am.
Okay. So
But
she would have, like, on this problem right here, she would have said 9, choose 2, and then in parentheses this would have been 40, and then raised to the second power, and over here would have been 60.
to the seventh.
And this, yes,
Okay,
that's what y'all would have done in class.
that logic makes sense.
Okay. Okay. So on this particular one, you tell me, what would I put for this for B?
It would be 15C7
Good job.
parentheses 0.50 to the seventh,
Uh-huh.
and then it would be 1 minus 0.50 to the eighth.
Yep.
Okay, that
She typically writes this, the 1 minus 0.50. She usually writes whatever that difference is, and I just go ahead and write the difference.
Oh, I thought 15 was a multiple choice problem. That was where I think my issue was.
Okay.
But you're technically, these are like 4 problems inside 15.
Yes.
Okay.
Yes.
Yeah.
That's it exactly. That's it. I'm sorry. I should have stated that before.
Not just because in science we're doing stuff similar to this with the scientific notations where it's like A, B, C, and D, and
Uh-huh.
I like doing it as a multiple choice problem. So
I
yeah.
got you. I know it. Yeah, it's kind of weird written that way, but the questions in the book are actually written this way also in the text. Well, I don't think we had you all doing a lot of stuff in the book, but I can't remember.
Yeah, I did it last night actually.
Oh, okay.
That's what that makes
All
sense.
right. So for letter C, you might not be able to see it actually. So let me go ahead and erase it.
15
Um,
C10
so it would be 15 choose 10.
to the 0.5 in parentheses to the 10th power.
Yes, sir.
1 minus 0.50 to the 5th.
That's it. Perfect.
Sweet. And then you just plug it in how it looks on the paper.
Yes. And you just want to make sure that you're doing those parentheses.
For sure. Okay. So, and then the next one, I think I would understand where to go. So, should we go to 16 or?
Yes, because that's going to be different in that.
Oh, it's 25%.
Yes, good job. So, and it's a 20 question test.
Mm-hmm. Oh,
Okay.
so instead of
So it's going to be 20, choose 5.
And then it'd be 0.25 to the 5th, and then 0.75, 1 minus 0.75, or
yeah, 1 minus 0.25, which is 0.75. So, however you would, how would you think of it?
mm-hmm.
1 minus 0.25, and then that would be raised to the 15th because
mm-hmm.
it's the difference between the 20 and the 5.
Yeah, for sure. Okay.
And then you would just plug that into the calculator.
And that would give you. It's hard to do on the TI 84 Plus without like the new one.
Oh, yeah?
It takes a while, yeah. Okay, this does make a lot of sense.
Yeah, it's not too bad, really.
I know it's not. Like, I guess like I felt it was more complicated because I don't know.
Well, the words, I think the terms are complicated. It just makes us feel smarter. It's like, when you call a bar graph a histogram, it just makes you feel that much smarter.
Yeah, for real.
Takes it up a notch.
Makes us Mensa smart.
Yes, that's right. So it should be something like 0.2023. Did you get that?
I didn't. I'm trying to plug in my computer to a charger.
Oh, okay.
It does totally make sense how you set it up and get to where you can solve it.
Yes. So, do you want me to do 17 with the histogram, or do you want me to move on to the expanding of the binomial stuff since that's an area that you struggle?
I think the expanding would be great to go to.
Okay, so you feel pretty good about number 17, and
Yes.
worst case scenario, just email me if you don't get that. Or and you know what? I will, now that I have this in PDF form, I'll email you a copy of it.
Thank you so much. I really appreciate that.
No problem. All right. So let's go down to use the binomial theorem to write the binomial expansion. And I don't want to confuse, I definitely don't want to confuse you on how I do it. But so I know that she does it with the 5, choose 0 at the as the multiplier,
Yeah.
correct?
Yes.
Okay, and see, this is where help me, Jesus. This is where I just write down these as the multiplier. So I don't ever write any of that.
Yeah, I only learned it the way that she did it. So would
Okay.
you mind going through
So
that?
okay, so I'll do it that way. So this is going to be then what you do is you take your first term, which is x, agreed, in your
Mhm.
binomial,
That's what you set it to.
and you raise that to the 5th power. And then you take your second term, which is -5, and it's raised to the 0 power.
Okay, and then you
And
go.
then you plus, and then you 5 choose 1,
Mhm.
and that's going to be x to the 4th, because your first term goes in descending order, and your second term goes in ascending order. So it started with 0, and now it's at 1, and the first term started with 5, and now it's at 4.
Mhm. I mean, the logic like totally makes sense. It's just remembering the order of which one's ascending, which one's descending. So
Yes.
the bottom term.
First term goes down.
And when you say first term, do you mean like the x?
Yes.
Okay.
So
And
whatever that would be, because it's a binomial, so it means there's two. So the first term is the x, and the second term is the -5.
okay. And you set the first term to the outside exponent.
Yes.
Okay. And it just happens to be the outside's also the second term.
Yeah, unfortunately, in this case, it is. Yeah.
And then you just go all the way until you get to 5 for the ascending order.
Yep.
Okay.
So it's now x is at 3, and -5 would be at 2. And then the next one is going to be 5, choose 3, x to the second, and then -5 to the third, plus 5, choose 2, x to the first. And I'm just writing that so you can see the ascending. Obviously, you wouldn't have to do that. You know what I'm saying? And that's going to be -5 to the 4th. And then 5, choose 1, x to the 0. I feel like I should be. Did I miss something? 0, 1, 2, 3. Oh, this should have been 4. My bad. Sorry, Chris.
Oh, I put a 4 there. My bad.
Okay.
Yes.
Okay. Good. Good. I'm glad that you did. Because like I say, I'm pushing myself out of my comfort zone because I just totally cheat on this. And I just look at Pascal's triangle, and instead of writing this, I just write the multiplier. Because when you plug this in your calculator, you'll get 1, 5, 10, 10, 5, and 1. That's what this 5 choose 0 part is.
Oh, so you're always gonna get 1, 5, 5, 10, 1?
For anything to the 5th power, yes.
Oh.
And like you're always, where is it? Like the next one that we're going to do is to the third power, and it's going to be, the multiplier is going to be 1331 every place that this little thing is. So then what you would have to do, you're not quite done yet. You would have to go in and plug this in your calculator to get that value, which is going to be 1.
Yeah.
And then you have to multiply that by other stuff. But in this case, this is going to turn out to be 1. And this is obviously 1 because anything raised to the 0 power is 1. So the first term is x to the 5th plus, and then you'll plug in the 5 choose 1 into your calculator, and you should get a 5.
Okay.
Times a negative 5, right?
So
which that's going to be negative 25.
Yeah.
So that's going to be negative 25 x to the 4th. And so then you've got that one. Now you're at 5 choose 2. And then you've got negative 5 squared, which is 25. And then you're going to multiply it by the 5 choose 2, which you should get 10, right?
Yeah. Oh, so basically like all the ones that are like choose 2, you solve for that, whatever it is.
Yes.
Then you just leave the x's, since you already found those, you just put those x's.
Yeah, I leave the x there, but the only thing I have to remember is I have to solve this part of my, I'm going to use a different color so you can kind of tell. I have to solve this part right here and multiply it by my multiplier, which is this piece right here.
So how did you get to 250? Because I know it's
because negative 5 squared is 25, and 5 choose 2 is 10.
Okay. Oh, we already are that far into it. Okay, I was looking at the 5c1 for some reason. Oh yeah, so 5 c squared makes sense.
Okay, because this right here, this term right here is this piece.
Okay.
And
oh, it's both of those pieces.
This term here is all of this.
Okay.
And let's see, let's pick a different color for this. This term here is this one.
Oh, so you're just essentially just solving them all together.
Yes, and this one is the one we're getting ready to work on.
Oh, I see. It's just the addition.
Negative 5 cubed is negative 125. And then this 5 choose 3 is 10. So I'm going to have minus 1,250 x squared.
Okay, because the it's negative 125 times 10.
Yes.
Okay, sweet.
And that is why I like this.
I would like that too. Like it makes sense. It totally makes sense to just like.
I'm like, I'm just like, can we not just give them Pascal? Because I made mine do a Pascal's triangle. They had to do one in class because I wanted them to understand the concept behind it. Because it's a beautiful thing. I just get very stoked about it. I was like, look, before the internet, what they had to do to entertain themselves. He found this incredible pattern by multiplying binomials. You know he was bored.
Yeah.
Anyway, so now we're actually on, let's see, which one are we on now, Christopher? We are on, I'm going to have to go back to using another color, that one that we've already used, but we're working on this term right here, and we're expanding it. And we have negative 5 to the 4th power.
Oh, why is it a negative? Oh, my bad. I was looking at the 5c4.
Yeah. Okay. That's the 5c4 is only your multiplier.
And you solve that in the calculator.
And you solve that in the calculator. If they don't give you Pascal's triangle, you solve that in the calculator.
That's negative 625, and then it's going to be 6. Is that what the Pascal?
The negative it actually should be a positive 625 because
yeah, my bad.
It is, so it's going to be a positive 625, and the multiplier for 5 choose 4 should be 5. So you're going to multiply that 625 times 5.
Okay.
And so that should give you 3,125x.
Is it an x squared or is it?
No, it's just an x because we're on this one.
Oh, my bad, my bad. I was looking at the wrong one.
And then this final one is just minus 3,125 because you've got negative 5 to the 5th power. And this 5, choose 5 is 1, and this is 1. So that really the only thing, much like the very first term, when you're dealing with the x to the 5th, you're dealing with the last term or the second term with negative 5 to the 5th.
Okay, so when it's plus negative, it's plus x5, then at the very end it's minus x5.
Yes, because on this one back here, you've got negative 5 to the 4th power, and a negative times a negative is a positive.
Mm-hmm.
Positive times negative would give you a negative, and then when you multiply a negative times a negative, you're back at positive.
Okay.
So this big long string of numbers is your final answer for number 18A.
So like from the plus x5 down to the minus 3125.
Yes.
That's the whole answer. Okay.
I'll rewrite it. X to the 5th minus 25 x to the 4th plus 250 x cubed minus 1,250 x squared plus 3,125x minus 3,125.
Okay. Thank you.
Uh-huh.
I just screenshot of that so I could look back for reference. So was that number 18?
That was number 18A.
Oh, wait, so there's more?
There's more fun to be had by all.
Wait, so 18A was
Yes.
okay. So
It's a binomial expansion of, and let me I'm going to go back up here since we've already worked that part. That way you can see the actual answer or the actual question. And it was use the binomial theorem to write the binomial expansion of x minus 5 raised to the 5th power.
oh, there's only 2 of them. I thought there was like A, B, C, D, which would take forever.
No, there's 2 of them there, and then finding the coefficient.
Mm-hmm.
That is similar. You kind of almost have to. You don't do the full expansion. You'll just count over. The first 2 are doing the full expansion.
For B, not that we have to work it out, but would that 3x stay the same the whole time?
No, it wouldn't because it's gonna be, and we can work it out. It's not quite as long as that one because it's only raised to the 3rd power, so it'll be a little less daunting. Mm-hmm. And that way you can kind of see how you're multiplying things out.
Like the 3x, so like maybe 3x1, 3x2, 3x3.
It would be, yes, you're gonna do the 3.
Wait, sorry.
Choose 0, and then 3 to the 3rd, x to the 3rd, and then y to the 0. Because everything in that first term has to be raised to the 3rd power. Does that make sense?
Yes, that's 3C0. Because
so that's going to be 3 choose 0 because that's the multiplier out front. And
oh yeah, it's because it's up to the 3rd. My bad.
Yeah, see, and so that's where I would choose to just use that line.
Oh, so you could essentially just do 1, 3, 3, 1 in your calculator with. Okay.
So this is how I would work this problem. If you'll bear with me a minute. I would just put 1 as because I'm going to use that particular row in Pascal's triangle. So I'm going to put 1 instead of all of this. And then I'm going to do this. Like that. And then my second term is going to be 3 instead of writing 3, choose 1. I'm just going to write down 3, and then I'm going to do 3 squared x squared and then y to the first. Does that make sense?
Yeah, it does. Does make sense.
Okay.
You're just taking out that 3c,
Yes.
just getting to the point.
Yes. And that's why I don't know. That's why I like to use it. But now I've kind of written all over the screen and it's like really bad. I got to clean it up. So which way do you want me to write it when we expand it? Because I want you to understand the expansion on that is that you have to raise that 3. And I know that there will be one on the test like that.
Mm-hmm.
You
I
know?
think the regular way would be great. Or like not the regular, but just the one that Miss Stone taught us in our class.
Okay. I will be more than happy to do that. Okay, so I'm going to go with a prettier color. 3, choose 0, and then 3x cubed y to the 0 plus 3, choose 1, 3x squared y to the first plus 3, choose 2, 3x to the first times y to the second plus 3, choose 3, 3x to the 0 times y to the third.
Yeah, that makes sense. Okay, so like,
now the very first one here, that's going to end up being this is 1 when you plug it in the calculator, and 3x cubed is 27x cubed. So that's the first term in the expansion.
Yeah.
Plus, and then this is 3. So 3 squared.
So it's 9.
Is 9 times this 3 right here is 27.
Oh, where's the y go? Does the y just disappear?
Nope. She's fixing to make her first appearance because this right here is equal to 1. So y makes her first appearance. Trying to get rid of that. Y makes her first appearance in the second term.
And just y. Okay, you just leave it as y. But yeah, those don't ever change. Okay.
Well, yeah, when it's because it's y to the first. See? Because it's going in this one's going in ascending order. It starts at 0 and then goes to 1 and then 2. And so because it's just a variable, it's only going to be, raised like this is just y to the first. And now this second time, this right here is also 3. And 3 times 3 is 9. So you'll have 9xy squared.
Mm-hmm.
And then this final term this is 1. That multiplier is 1. And then this is 1 because 3x to the 0 is 1. Anything raised to the 0 power is 1. So that's going to be plus y cubed. And there's the expansion of that one.
That makes sense. Yeah. Okay, thank you.
No problem. So now for number 19, where you have to find just a coefficient.
Would you just go to the 5th?
You would go, it says, how big is it? Is that the 6th? Okay, so you would go, which one, knowing that they go in descending order, where would x to the 5th be? Which term would it be?
Would it just be 1? Or I mean, it's
5. Which term? Because like if you're thinking about it, there is the terms of the original binomial, but when you're expanding it, it's going to have 6 total terms because it's raised to the 6th power.
So x would just be the 5th.
It's okay. So it's raised to the 6th power. So there's going to be a total of 6 terms, correct?
Yes, ma'am.
Okay. So if you're finding the coefficient of the term that has x to the fifth in it, where would that term be?
Um, it'd be the fifth one, right?
It would actually just be the second because this is your x,
Mm-hmm. Oh,
and
actually,
then the very next term, because they're going in descending order, the very next term.
I was thinking ascending order. My bad.
I'm sorry.
I was thinking of it as an ascending order, but
Oh yeah, the second term is in ascending
okay.
order. So
And that's
that's
for
0,
expansion.
-3, and that goes to 1. So now what we would have to do is get in the expansions. Okay. So like what you're doing, like what I would do, maybe this isn't really a good, since I knew it was x to the fifth
Mm-hmm.
here, I know that's the second term. And I know this is 6. I would do 6, choose, and then the first term is 0 and the second term is 1. So it's 6, choose 1. Okay.
Mm-hmm.
X to the fifth. And then it'll be -3 since this is 1
The
to
one,
the first.
and that's it.
Well, you'd have to plug all that in your calculator. So when I think 6, choose 1 is 6.
Oh wait, so like you're setting it. So why did he set it up 61 x 5 -3 1? Is that because it was x to the fifth?
Um,
Or I guess like I'm asking like if it was like x to the fourth, finding the coefficient of x to the fourth in the expansion, like how would that look different from the?
okay, good question. If in this same expansion,
Oh yes, ma'am.
okay, great. That's a really good question because I think that'll help differentiate it a good bit for you. If that were the case, like basically, you know how I like to make a space for everything.
Yes, ma'am.
Um, so I'm on this one. I've got x to the sixth. I know that one. X to the fifth. X to the fourth, like that.
Mhm.
So um, this is 6, choose 0. This is 6, choose 1. This is 6, choose 2. So it would look different in that this number would change and it would be a 2, and this number would change and it would be a 4. And this number would change because it would have gone up 1 and it would be a 2. Because the second term
Okay.
is the one that's ascending.
So like
And
you could technically kind of work them all out and just so like if I was like on the test, I could do all the expansions for like x to the sixth, x to the fifth, x to the fourth, and then just circle x to the fourth expansion, and then just plug that into the calculator for my answer.
yes,
That helps to just do them all.
yes, it
Okay.
does. And I will tell you, when Mrs. Stone works it out, she does do all of that every single time when she works them out.
Okay.
Um, and I just, if I have the Pascal's triangle in front of me, I just count over to the third term. Like I'm telling you, she's so much not lazier than me. I'm lazy, Chris.
Well, I don't think it's lazy. I think it's just like you're working smarter, not harder.
I don't know. I guess. But so that's kind of that's how you do it. I'm like impressed that she can see all of those choose. I really have to force myself to push that because last year I had a couple students for sure that preferred that method because I taught both methods.
Mhm.
But they definitely preferred that. So let's talk about this next one because the wording is a little different. It's like find the third term
Of x.
of x squared minus y cubed. So let's just, first of all, let's go with you're going to have 3,
Mhm.
choose 0. That's going to be our first term. okay, with an x squared all raised to the third power times a negative y raised to the 0 power plus 3 choose 1 with x squared raised to the second power and negative y raised to the first. And then the next one is going to be 3 choose 2 times x squared raised to the first and negative y raised to the second power.
Oh, I had a question. So for these,
Yes.
like when it's like x squared in parentheses to the third power, would you add those exponents so it's like x to the fifth?
No, sir. When it's a power raised to a power, you multiply those.
But would you just leave it like you have it, or would you do like for the first term, would it be 3CO to x to the sixth?
Yes, perfect.
So would you do that in your calculator?
No, I mean, no, I wouldn't.
Oh, so,
You would just the only thing that you're going to put in the calculator is that 3 choose 0, which should give you 1.
oh, I got you. Okay, and then
So then you would have x to the sixth,
mm,
and that's going to be the first term. So
okay.
that's the first term.
But it's only asking for the third term.
Yes, and this is the second term. So you wouldn't even have to go to all the trouble to expand everything out. So now we got the second. This is the third term, and that's the one it's looking for.
Okay.
Okay. So I know that 3 choose 2 should be 3.
And I don't because I don't use the Pascal triangle, but I would if I was in your class.
And so then I have 2 times 1, which is x squared. And then I've got negative y squared.
Okay. Negative y squared. That makes, I mean, so that's all it is.
Yes.
So it's just 3x squared and then y
So
squared.
it's going to look like that because negative y times negative y is positive.
So that's the answer.
That's, yeah, the 3, this right here, this beautiful little tiny number is really the answer.
That's so interesting because like I never understand how to do these problems in the book. So whenever I go back to look at the answers, it now makes sense to see where those answers came from.
Yes. And please note on this one where it says find the coefficient of x to the fifth,
Mm-hmm.
I don't think I finished that one all the way out, so my apologies. When it says coefficient, it's not looking for the whole term. It's just looking for the coefficient. And I don't think I finished that one all the way out for you. And that means just like if it was asking me on this particular one for just the coefficient, it would be just 3.
Oh, so the third term. Oh, okay.
If it asked me for the coefficient of the third term, it would be looking for just the 3. In this particular case, the question is find the third term. So 3x squared y squared is the complete answer.
Yeah, that makes sense. That makes a lot of sense. Okay, and then the coefficient's just asking for one number.
Yes, for the number, in front of all the beautiful sets of letters that you get.
If like
I apologize. The answer to number 19, so that you know, is negative 18. And I don't think we got to that. But technically, the second term, this right here would be the second term. So it would be x to the fifth times negative 3 to the first with the multiplier out front. And the multiplier is 6 because that's that 6 choose 1.
Yeah. Okay. So
it would be 6 times negative 3, which is negative 18.
Okay. So
X to the fifth. And since it asked for just the coefficient, it's that.
That makes sense. So like on number 20, if it was asking like to find the coefficient, like what if it's like, in this case, it's x squared minus y. But what if there's a number in front of both the x and the y? So like
you would have to incorporate multiplying those, much like we did. You know how the number for number 18, which you took a screenshot of, I believe, how the numbers were just like really ginormous. They were crazy. Like first one was like negative 25, which wasn't a big deal. But then we got 250, and then we went to 1,250, and then we went to 3,125 because the number was negative 5.
So, like, if you have a bunch of numbers, whether it's the x or the y, when you're like finding the coefficient, you just multiply all the numbers in that term.
Yes, you multiply all those individuals. So, like if you're squaring them or cubing them or doing whatever, you have to actually take that action on that number as well. And then I call this thing out front, this thing where she's doing the 3 choose 0 or the 3 choose 1. That's what I would call, I keep referring it to a multiplier, because you're literally multiplying each term by the same thing each time, but your terms might change because your binomial changes.
I
So
got
whatever that 3 choose 0 is, or 3 choose 1, or 3 choose 2, that's your quote unquote multiplier. So once you get the result of whatever all this is, that final result of, say, if this happened to be a 2x squared cubed, then that would be, 2 cubed, which would be 8. So then you would take 8 times whatever's on the outside, or that 3 choose 0, 3 choose 1.
you. Okay, so so I guess for like number 19, where you have the term set of like 6x5 minus 3, 1.
Yes.
If you had a y right after the -3, would it still be -18?
Yes.
Okay, so
It
like,
would. The coefficient would still be 18, but your term would actually be -18 x to the fifth y.
that makes sense. But so the coefficient's not affected by the letter it's with when you're trying to find the coefficient.
No.
Okay, thank you. Because I know a lot of times you're not supposed to like cross multiply the y's and the x's.
Right. I got what you're saying, but no, the big thing is to make sure that you're squaring or cubing or doing whatever that particular term, that piece of the term does.
Okay.
I don't know if I worded that well.
Yeah, I mean that helps a bunch. Yeah, because I always thought like you couldn't multiply. That I probably would have got messed up on the test tomorrow if I didn't know what you just said.
Okay.
So that helped. Thank you.
Okay, no problem. Um, oh, whoops. Sorry about that.
Is it
Um,
20?
so I don't know if I should try to rework out, since I didn't do the coefficient. Well, I guess I kind of did the coefficient. I don't know if you want me to expand it, this whole thing, just to have another exercise in expansion.
I feel good about it. I mean,
Okay.
I feel like you really helped a bunch. So is that the review sheet?
Yep, that's it.
Thank you so much. Oh my gosh, I didn't realize it was almost 6. I do have
Oh,
to.
no problem. No problem. I'm happy. I'm happy to help. And we had let's see, we had a couple people join us and then leave. Lainey came in and left, and Caitlin is still. Oh, Caitlin just left.
Oh,
So I don't know. I don't know if she had any questions. I'll just email her.
well, thank you so much.
Not a problem.
Your time out of your day. All right, see you tomorrow. Bye.
Well, I would do math lab for an hour anyway.